So I have a binomial times a trinomial. So I'm using the distributive property, except I have two terms to distribute. So I'm going to take that x times x squared to get x to the third. Then I go back and I take x times 3x to get positive 3x squared. And then I go back and I take x times negative 6 to get negative 6x. Then I go to the 4 times x squared, and I can put plus 4x squared. Then I can go back to the 4 to 3x to get plus 12x. And 4 to negative 6 to get negative 24. So, like, it's doable. I have fairly large handwriting, but you also don't want to write so small that, like, you can't read what you wrote and you make a mistake. But, like, I can fit it. Then I collect like terms. I have x to the third is by itself. I have plus 3x squared plus 4x squared is positive 12x squared. Then I have minus 6x plus 12x is plus 6x. And minus 24 is all by itself. And I'm done. I just multiplied a binomial times a trinomial. So that's one way of doing it. You just write it all down. We can't say FOIL first, outside, inside, last because we have to do more than 4 steps. Another organizational strategy. For number 2, we have k minus 5 binomial times k squared minus k minus 8 trinomial. Get a little, I don't know what you'd think that is, but. So again, I take k times k squared to get k to the third. K times negative 1k is negative 1k squared. K times negative 8 is negative 8k. So another organizational strategy, when I switch terms, negative 5 times k squared, I'm going to line up my like terms, negative 5k squared. I'm going to make them vertical. So then I don't have to look horizontally. Oh, Seth, yes, you're right. Sorry, I multiplied. I had multiplication on the brain. That should be 7x. Good catch, Seth. 3x squared plus 4x squared is 7x squared. Negative 5 times negative 1k is positive 5k. And negative 5 times negative 8 is positive 40. So another organizational strategy is to line up your like terms. It could make it easier for you to start combining k to the third. Negative 1k squared minus 5k squared is negative 6k squared. Negative 8k plus 5k, negative 3k plus 4d. Same answer as if you wrote it all in one line. So again, it's fairly easy. It's not as haphazard and messy if it's a binomial times a trinomial, or a binomial is your leading polynomial. It does get a little bit harder to look at if you increase to a trinomial times a trinomial, or even something bigger. And then the third way of organizing is to do the grid, which I find is like the one that middle schoolers pick the most. It's a little bit more aesthetically pleasing. So this is a binomial and a trinomial. So there's 2 terms and 3 terms. So I'm going to draw a grid that is a 2 by 3. It does not matter if you draw a 2 by 3 or a 2 by 3. It doesn't matter. Typically speaking, we go this way just because it fits on our paper better. The trick to this is make your boxes big enough that you can actually write in them. And because it's a binomial, 3a, first term goes in 1 plus 1, the second term goes in the second one. My binomial goes on the side with 2. My trinomial, 5a squared plus 2a minus 6. Remember that operation belongs with the term? In science class, you do something similar to this. It's called a Punnett Square. It's when you do heredity. Like if your mom has blue eyes and your dad has brown eyes, what are the chances of their children's eye color? Do you remember doing those in science? Have you not gotten there yet?
No. We haven't touched on that subject yet. We're just doing space.
Oh, it's 7th grade science.
Yeah.
I did this in math.
Yeah, we did it in math, but we have never done it in science.
Oh, all right. I mean, science has changed since I taught it a billion years ago. But we multiply. We take 5a squared times 3a, and that's 15a to the third. And then we take 5a squared times 1, and we get 5a squared. Then I move on to the next. 2a times 3a is 6a squared. 2a times 1 is 2a. Negative 6 times 3a is negative 18a. And negative 6 times 1 is negative 6. You're going to get the same thing if you distributed. All right, if I took 3a times 5a squared, I'd get 15a to the third. And if I took 3a times 2a, I'd get 6a squared. And if I did 3a times negative 6, I get the same thing. The nice part about this organizational strategy, not all the time, but most of the time, forgot to grab highlighters. Your diagonals are like terms. Not all the time, but oh, that purple is real purple. Sorry. Meaning 15a to the third, 5a squared plus 6a squared is plus 11a squared. 2a minus 18a is negative 16a minus 6. Same answer. It's just a little bit more organized, a little bit easier to look at. Now, it's your choice. You pick how you want to do number 4. Do you want, oh my gosh, to double distribute and make a long line? Do you want to double distribute and stack them? Do you want to grid? Here's number 4. You pick whichever one you feel the most confident with. Two v plus 3, 4v squared minus 3v minus 6. It's your choice. You can do this however you want. Because all 3 give you the same result. All 3 of them, you write down the same number of terms. it doesn't change anything. Uh, 2v times 4v. Hold on, I have to talk myself through this. The numbers you should have gotten are on the board. Yours may look different. It may be in a different order. But those are the 6 terms you should have gotten when you multiplied. Because you did 2 terms, a binomial times a trinomial, right? 2 times 3, you're going to have 6 terms. Now, your answer is not going to have 6 terms, most likely, because we have like terms. If you did the grid, they should be diagonal to each other. Not always, but should. And you get 8v to the third plus 6v squared minus 21v minus 18. Agree? So, I mean, I guess since we all got to pick what we wanted to do, you can tell this is the way that I prefer to do it. But that's only in a binomial times a trinomial. Right? And, you know, it's quote unquote less work to not have to draw the grid. Right? Like that extra 15 seconds I'm saving. It's not that big of a deal. However, number 5 is a trinomial times a trinomial. My handwriting can't handle a trinomial times a trinomial. My handwriting's too big. It's too many. It's going to be 9 terms that I have to keep in order. 6 is about my limit. 9 is where I think to myself, all right, I don't think I can keep that in order. Let's put it in a grid. Now, part of the other issue with grids, you have to get pretty okay at drawing them. There's a lot of erasing in the beginning. Yes?
Can we do it a different way?
Can you do it one of the other, like, organizational? Yeah, that's fine. If you want to list them, I think once you get to like a trinomial times a trinomial, doing that first one where you just list them all in one long row tends to be a little chaotic. But again, I can put this first trinomial wherever I want. Do you want to put it on the side or the top? Doesn't matter. As long as you put one of them there and one, right? So z squared plus 2z minus 3. Negative 2z squared minus 4z minus 10. Z squared times negative 2z squared is negative 2z to the 4th. 12z squared times, no, negative 12z squared, no, oh my gosh. Negative 12z times negative 2z squared is positive 24z to the 3rd. Negative 3 times negative 2z squared is 6z squared. Z squared times negative 4z is negative 4z to the 3rd. Negative 12z times negative 4z squared is positive 48z squared. Negative 3 times negative 4z is positive 12z. Next row. Z squared times negative 10, negative 10z squared. Negative 12z times negative 10, positive 120z Negative 3 times negative 10 is 30. Yes?
Or are you getting negative 12z on the left side?
Oh, nuts. That should be plus 2z, not minus 12. Seth's been saying the same thing.
I mean, it's simple enough. We can just remove the first two numbers
Oh.
of the second row. You just remove the first two numbers.
Okay, where's my whiteout?
Meaning for
This row is wrong, right?
Well, as for quote unquote 24 z to the third, we could have just removed the two.
All right.
Just remove the two, and then for the 48 z.
This becomes 4z to the third, yes?
Yes.
This is negative 8z squared. And this is negative 20z. Everything else is right, correct?
Yeah. Literally all I had to do was just remove the first number and just put a negative in front of it.
All right, so now, like terms. Negative 2z to the fourth. Cancels out. No z to the third. 6 minus 8 is negative 2, minus 10 is negative 12z squared. 12 minus 20 is negative 8z plus 30. Right? It's hard to get in there. If once you get more than 6 terms, it's hard. 6 is about the limit. All right, let's see if I can not screw up number 6. Who knows? Maybe I'll use better handwriting. It's a 3 by 3 again. Negative 4y squared plus, nope, I already screwed up. Minus 5y plus 3. Then I have negative 1y squared. I'm putting that coefficient in. Negative 1y minus 1. Lots of ones. I told you, sometimes when I make up these problems, I get stuck on things. Negative 4y squared times negative 1y squared is positive 4y to the fourth. Negative 5y times negative 1y squared is positive 5y to the third. 3 times negative 1 is negative 3y squared. Negative 4y squared times negative 1y is positive 4y to the third. Negative 5y times negative 1y, 5y squared. 3 times negative 1 is negative 3y. Negative 4y squared, negative 1, positive 4y squared. Negative 5y, negative 1, 5y, 3, negative 1, negative 3. Did I manage this one? I'm okay?
You got it right.
All right, 4y to the fourth. 5 and 4 make plus 9y to the third. Negative 3, 5 is 2, 4, plus 6y squared. Uh-oh. Started out too big. Plus 2y minus 3. Barely made it. Yeah, did you have to overcome the great debacle of minus 12 is really a plus 2? It also sometimes, like some variables, if the variable is the letter B, my problem takes like 3 times as much room. It's all kind of just out there. All right, one more. And then we'll do an easy one to kind of talk it through. You pick how you want to do it. Do you want to grid it? Do you want to... I guess I can show you that you can stack it on this one. It's, again, up to you. Oh, golly Moses. Just kidding. I didn't realize this was a polynomial. Not a or a trinomial. All right, I'm going to grid. Stacking's too much. It's going to be big. Because here's the other thing. Did you notice that there's a mixture of variables? Right? So that means it's going to be even. I mean, it's going to be a 2 times 4. It's going to be 8 terms long. Plus, there's a mixture of variables, so that's even less things that get combined. I like your confidence. I quickly bailed. All right, so negative 5 minus 10. And then make sure you write this down correctly, Mrs. Long. Whew. All right, negative 20x to the third. Negative 40x squared. 25x squared. 50x. Negative 35xy. Negative 70y. 10x. And 20. You should have 8 terms. Do your 8 terms match my 8 terms? Now here's what I was talking about. How we talked about how they're usually diagonal. They are not all diagonal in this problem. I have x to the third, so I start there, negative 20x to the third. Then I have x squared, which is negative 40 plus 25 is negative 15x squared. Then I have this guy, right? Because it has a degree of 2, negative 35xy. Then non-diagonal, 50x and 10x is plus 60x, minus 70y plus 20. Woo! Yeah, right? I mean, that's a big one. All right. Last but not least, we talked about this in the notes, but we'll talk about it right now. A 2 by 2, you can also, if you're like, man, I love this grid. I love making the grid. You can make a grid for a 2 by 2. You can do this for a binomial times a binomial instead of doing FOIL. You can do 7x minus 9. And negative 3x minus 2y. Sometimes this is called the table method. I can get negative 21x squared, positive 27x, negative 14xy, and 18y. I can use the grid. Now in this one, I don't have any like terms, but they'd be here if there were. Negative 21x squared minus 14xy, degree of 2, plus 27x plus 18y. It can get big fast, and it can get ugly fast. Find a way to organize your work. Also, make sure that your plus sign doesn't look like a negative 12. Thank you for joining us online students. I'll see you tomorrow. Pictures, turn it in, yada, yada, yada. You guys, same thing.
Wait, you can tell them the homework.
Yeah, they'll figure it out. They have to go to Canvas to click on the assignment. Listen, don't you use that excuse. Don't you say with the questions I get. Yes, Xavier. Yes. Don't try to play the I never can't figure something out game. Spent half the year trying to convince some of you guys you had to write things down. I did not do a good job of looking at the chat while we worked today because Seth was all over it. Where's the 12? Mrs. Long, I don't see a 12. There is no 12!
That sounds familiar.
Right? Oops. Listen. Even Mary Poppins is practically perfect. Nobody's totally perfect.